Hey everybody, Mr. Stewart here, and welcome to this particular screencast that's going to take us into learning about a couple of other exponent laws. Okay, so first things first, what we should do is sort of warm up our minds to using different tools in order to visualize those particular laws. Okay, so mathematics is full of patterns, and those patterns can sometimes be visualized using graphs, tables, equations. So we're going to look at those things here today. So first things first is have a look at the grid that's there and decide for yourself, what is it that you recall, okay, about your previous experiences. I want you to think and jot down some ideas of how you could describe or show as much as you can about what you've done with that kind of diagram in the past. So take a moment and pause the video and jot those ideas down. Okay, so let's take a look at a few ideas, and this is not a complete list. You probably have a lot more than this, but you might have said something along the lines that I would graph with this. Okay, and a graph is nothing more than a representation of data. Okay, so in this case, the data is going to come from a series of ordered pairs. Okay, so that graph is a result of plotting what some people would call points, or more formally, something known as an ordered pair. Okay, so an example of that would be x comma y. Okay, so every ordered pair has an x coordinate and a y coordinate. So x would be here, and y is the horizontal axis. Okay. For an example, you might have decided to actually plot a point or plot something more than that. So let's say that we took on the point, let's say -4 and -3. Okay. So if we head in the left direction, that is left of 0, so we'll move in this direction here along the negative x-axis. And if we scale this out, -4 is here, and using a similar scaling, -3. So, of course, where those two connect is more or less where x marks the spot, or we would represent that with a point. Okay? So that is our ordered pair, -4, -3. And so you might have been thinking those things. Okay? So the surface you're graphing this on is also known as Cartesian Plane. And so it's named after a mathematician. It's Cartesian Plane, or the XY plane. So it's for graphing points in 2 dimensions. Other things you could say about this that you might have heard somewhere in the past, okay, is that there are 4 quadrants. So this is known as quadrant 1. Okay, so that's where x and y are both positive. So x is positive and y is positive. Quadrant 2, or Q2, is over here. It has a negative x and a positive y. Q3, or quadrant 3, is here. Both x and y are negatives. And over here we have quadrant 4, where x is positive and y is negative. Okay. You might have also thought about the following. So we have 3 ideas working here. You might have also looked at graphing different relationships. So if you have a collection of points that seem to follow a very specific or defined pattern, you might have graphed some relations. So you might have thought about perhaps like a line. I'm just going to draw a few random points here that all seemingly lie upon the same line. So you might have done that. So I'm just going to connect these with the line. Okay, so that's a possibility. So that could happen. put arrows on the end and indicate that that could go on forever. You might have thought a curve, okay? So you might have done something that's non-linear, okay? So it could have looked anything like this, okay? That kind of a curve. It could have any particular shape, okay? So those are relations. So to continue to warm up, have a look at this particular slide here. And what I would like you to do now is, again, I'm going to have you pause the video, but I want you to think about the following. Okay, here's your prompt. So for those three graphs, okay, just going to move this one out of the way, I want you to think about the past, and I want you to contrast the graphs of those relations or relationships. And remember, to contrast means to both compare, which is compare or discuss similarities, and also contrast means to talk about differences. Okay? So pause the video and jot a few ideas down in space. Okay, so you've gone through, you've done a little thinking and jotted some ideas down, things that might have come to mind. Okay, so for instance, you might have said that this graph is linear, given that it's a straight line. And you might have gone so far as to say over here that both graphs B and C are nonlinear. You might have also thought back to an earlier time and realized that this specific type of graph in B, not only is it nonlinear, but it's a special type of nonlinear relationship. Okay, so this particular relationship is known as a quadratic. And the name of its graph, okay, so the graph has a specific name that's known as a parabola. So you may have recalled that U-shaped curve from your last math course. The one in C, of course, it's nonlinear too, and that's going to be a new one for us. You may have seen it depending on your previous course, but this is known as an exponential relation. And we'll kind of study the how and the why that it is exponential. Okay. One thing you should do before leaving this particular concept is just to contrast what makes linear versus nonlinear. And it's easy to say that one's a line, one's a curve. But something you do need to know, okay, and recall is that between any 2 points on a line, okay, the slope of the line between any 2 points, okay, is equal. So for instance, with this one here, you see there's a rise of 2, and then across the bottom, depending on the scale, okay, again, if these are single units, across the bottom, and then across the top, or the side, these are single units as well, that I have a measure of 2 over 2, okay, as the run is 2 units wide, and then the rise is 2 units high, okay, so 2 over 2. Same thing happens here, as this is 1 over 1. Okay, so the slope of the line, of the rise compared to its run, is 2 over 2, which is the same ratio as 1 over 1 in the smaller triangle, or otherwise known as a slope of 1. So that's what defines a linear relationship. But nonlinear, okay, there isn't a constant rate of increasing or increase. Okay, what we say is that these functions or these relationships, they are always, in this case, this is not the only possibility. There are decreasing functions, but each of these is an increasing relation. Okay, they're increasing. Whereas this one here, although it looks like it's increasing, what we say is that there is a constant rate of change. The change in the y values is constant as it's compared to the change in x. Whereas over here, the increase, you can really see it if you draw in what we call rate triangles. Right? You can get an idea of how the slope is absolutely growing, okay, with each particular succession, right, from point to point. The same thing happens over here with exponential. If I draw in these rate triangles or right triangles between consecutive points, you can see very quickly how the growth is nonlinear. Okay, it's always increasing. So that's a bit of a review and a bit of a warm-up on different types of relations. And the reason why I've had you gone there is for the simple fact that we can use graphs to prove and establish new relationships in math. Okay, so as we kind of get into the remaining pieces or parts of the video, we might end up breaking this one into two, okay, just to kind of keep it sort of in that 10 to 15 minute range, and then we'll break it into another one. Okay, so here's a little foreshadowing of what's to come. Okay, so what I'm going to have you do is to consider the following question. Okay, I would love for you to use the graph, and I want you to complete the middle column. That is this column right here. This column labeled 2 to the x. Okay, so these are your x values here, and these are otherwise going to be known as your y values. Okay, so I want you to try to complete those. So in quick review, just to get you started, take note that this point over here, just for example, say, okay, is the point 2, comma 4. And down here, if I take this one that's identified, so at negative 2, okay, with this point, I seem to have minus 2 for x, and then the y value here is about a quarter of the way from 0 to 1. So that would be positive 0.25. Okay, so I'd like you to go through and complete that chart. So pause the video and give yourself a chance to get caught up. Okay, so you filled in that middle column as per the instructions. So I'm just going to click the reveal. So working our way from minus 2 on the left, so from the negative values, we're increasing x. Okay, typically that's how we fill in the table of values, is we have increasing values of x, and then we always study the resulting y values from there. So you can see how it is growing from 0.25 all the way up to positive 8. Okay. You can also represent that a little differently. You could have also thought about it in a fractional form. Okay, 0.25 is a quarter, 0.5 is a half. Okay. What's important at this point in time is to recognize patterns. Okay. So have a look at the table and decide what patterns or what patterning do you see. So again, pause the video and give yourself a chance to think that through. All right, so having gone through that, you probably recognize that there is some patterning happening here. So what you can see in the x values is that these ones are increasing by 1. So that is through an addition of 1 unit all the way through. Whereas these values here, okay, they're not increasing by a constant amount. That is, we're not adding the same amount. There is no common difference. But what we are seeing is the fact that they are doubling. So we can see a multiplication by 2 all the way through the table, times by 2. Same thing happens here. Doubling a quarter, you make a half. Double a half, you make 1 whole, and so on, and so on. Okay, all the way through. So that has great significance for us in how we can complete the table, use the pattern to extend the graph, use the pattern to come up with an equation, and that's going to come out later on. So the next move for us is to take time out and to do some reflection. Okay, so I think what we'll do is we're going to stop this particular video here and have you sort of finish your notes and summarize, and then I want you to get into the second part. Okay, so another 10 minutes or so, and we're going to try to consolidate some findings from those tables